Good morning. We'll be starting up here in a couple of minutes. While you're logging in, you might as well go ahead and open up your Q&A pod at the bottom and your chat pod. The chat pod is closed for your comments, but we'll be putting in resources and links and things like that there. So we'll be starting up in about a minute or so. And again, if you haven't heard this, go ahead and open up your Q&A pod and get your chat pod set to go and stuff like that. Okay, well, we'll go ahead and get started. Good morning. My name is David Orr. I'm the director here with the Local Roads Program here in New York State, with the Cornell Local Roads Program down in Ithaca. And welcome to one of our foundational webinars. Today we're talking about culverts, and our instructor is Willy Grimmke, who was with Washington County for how long?
13 years.
13 years. Time flies when you're having fun.
Oh, yes.
And now works for us part-time, along with his full-time work working in consulting, doing training on local roads done right, and well, maybe we'll get him busy on some other things. Today he's going to be talking about culverts. I'll let him introduce himself a little bit more. Again, open up your Q&A pods and chat pods, and I'll let Willie get started and go dark myself. If you have any questions, put them in, and we'll go from there. It's all yours, Willie.
Great. Good morning, everyone. Welcome to Keeping Your Culverts Well. I'm Willy Grimmke. As David mentioned, I'm the former county highway superintendent in Washington County, New York. I currently work for Greenman Peterson, doing consulting with construction inspection, as well as providing training for doing NHI courses. We're going to talk a little bit about preservation techniques and maintenance of culverts today. Culverts tend to be the red-headed stepchild of the bridge world. They're often not thought about until you have a problem. We have little orientation. You can raise your hand if you have questions. You can put questions in the Q&A or hit up the chat pod. Make sure you can hear me, and if you have any questions, type it in. So this provides professional development hours. You'll get if you're a licensed engineer in New York State, you're eligible for a PDH for attending this, but only for the person who is registered for the webinar. So you should get sent a certificate of attendance. Other states, I honestly don't know. Check with your local LTAP center in those states. So, learning outcomes. What we're going to discuss today are common deficiencies identified in culverts. We're going to describe preventive maintenance of culverts, and we're going to review some basic culvert repair techniques beyond just tearing them out and replacing them. So we're going to start out with some poll questions to sort of get an idea of where we are and who's attending today. What's your primary job function? Are you a highway maintenance worker, highway maintenance supervisor, an engineer, or other? Okay, it looks like we have overwhelmingly engineers, as well as some others, and we've got about 15% from the highway maintenance community. Great. So next, who do you work for? Village, town, county, city, state, or private sector? Okay, we've got 4% village, 18% town, about a quarter county, 13% city, 15% state, and a quarter private sector. Okay, so we've got quite the variety here. How long have you worked with culverts? Less than a year, 1 to 5 years, 5 to 10, 10 to 20, or over 20, lots of experience with culverts. Okay, so it looks like we've got some newbies. We got almost a third in the 1 to 5 category, and we've got almost a quarter in the over 20-year category. All right. So, and then how many culverts in the 5 to 20 foot span are in your system? If you're a public employee or you're responsible, is it none, 1 to 10, 10 to 25, 25 to 100, over 100, or I have no clue? Okay, so we've got over a third with over 100 in their inventory. We've got some with none, some with not sure, and then we've got others with varying numbers. Okay, so let's talk about culverts a little bit, and we're going to start out with some nomenclature so everybody's on a common knowledge base, so we know what we're talking about. Down at the bottom of the culvert, where the water flows, that's referred to as the invert. The top, the peak of the culvert, is referred to as the crown. The widest location is known as the spring line, and underneath the culvert between the invert and the crown is an area known as called the haunch, which we're concerned about the bedding in underneath the haunch, which is critical to supporting the culvert when it's installed. In cross section, we have often, but not always, coming into the culvert, an apron. We may or may not have a toe or cutoff wall, which will prevent water from flowing in the soils and the bedding beneath the culvert. Sometimes we will have wing walls. Sometimes we will have a head wall or parapet retaining the fill above the culvert. we will always have a barrel, which are the walls and top and bottom of the culvert. Some culverts may have end sections in lieu of wing walls and aprons. Precast or prefabricated sections of culvert will have a joint that will extend radially around the culvert. And culverts come in a variety of shapes. They may be round, they may be elliptical, both horizontal as shown in the lower left, and sometimes there are vertical elliptical culverts, and these are dictated based on the geometry of the stream channel and what's crossing above and below. We may have box culverts, as shown in the center top photo and the center diagram, and in the center diagram, we have a bottomless culvert, and those are becoming much more common with the environmental folks wanting us to retain a natural stream bottom as much as possible. We may also have, as shown in the center bottom diagram, metal boxes. We may have bottomless metal arches, and we also may have plate arches or pipe arches, which is the odd kind of shape in the lower right. Now, culvert materials. Common material is concrete. Concrete can come in a variety of shapes. It may be precast. It may be cast in place. Concrete, but in and of itself, is rigid, and that provides the support. However, it needs to be adequately bedded, and in upcoming slides, we'll show some of the issues with bedding or poor bedding and what indications you'll see in culvert distress if the bedding is not done correctly. Nice thing about concrete is it has smooth interior, so you get good hydraulic characteristics through it. For round concrete pipe, they're typically joints in 4 to 8 foot spacing, and sometimes concrete may be skewed, particularly with box culverts. Here's some photos of concrete types. We have round in the upper right, and we have a bottomless precast box on the lower right. We can use horizontal elliptical in low clearance situations. There are some manufacturers that make precast concrete arches, and cast in place concrete boxes are sometimes built also. We move on to culvert materials and corrugated metal, which is fairly common, although for smaller diameters, corrugated plastic or corrugated polyethylene is becoming more common. Now, in this particular case, the materials are flexible, and they will flex and bend with movement and settlement in the soil. And this makes the installation and compaction of the surrounding soil critical for the long-term structural performance of the flexible culverts. The soil is actually providing the vast majority of the load carrying capacity, and the flexible culvert is essentially acting as a form for the backfill and compaction of the soil. With the corrugated metal pipe, the corrugations provide a rough flow surface, which may reduce flow a little bit. Typically, the joints are about 20 feet apart with both flexible, with both metal and plastic. Plastic, we have both corrugated interior, and we also have smooth interior, which is common, which has similar hydraulic characteristics to the concrete. The metal culverts come in both steel or aluminum. In some areas, aluminum is common, and that will have pretty good corrosion resistance. Round culverts extend up to 15 feet in diameter. Plate pipe arches, which are individual plates that are bolted together, can span up to 50 feet, and bottom arches up to 55 feet. Again, they're flexible. In the preformed pipes, joints 20 feet apart, and in the plate pipes, there is a random pattern of plates in the 6 to 8 foot square-ish shape. I talked about polyethylene. Again, like metal, it's flexible. It may have smooth or corrugated interior, and very much like the metal, it is highly dependent on interaction with the surrounding soil. And in both of those cases, during installation, soil compaction of both the bedding and backfill is critical to the long-term performance of your culvert pipe. So I can't emphasize enough proper installation and maintenance necessary to make the culvert last as long as you're planning it to last. And proper maintenance can delay or prevent complete or open cut replacement. So common defects that we often encounter in culverts are debris and siltation, which can impair the ability of your culvert to pass water as it's supposed to. We can get leaking joints. Those leaking joints can lead to settlement and sinkholes. We can get scour and undermining at the inlets and outlets, and that will be due to how the culvert is situated in the channel. It may also be due to accumulation of debris at the inlet and outlet. We can get damaged coatings in the case of metal pipes. They're typically galvanized, and that coating protects the pipe from corrosion and other deterioration. We can get invert damage or deterioration. It may be due to corrosion or damaged coatings, and in concrete and other pipes, concrete and plastic, it could be due to abrasion based on the bed load. We can get dense and localized damage, and that can be a result of debris carried by the stream, or in some cases, installation errors. In concrete, we can get cracks and spalls, and we can also get deformation of the pipe with the flexible pipes, which can happen as a result of installation related issues. So we'll start out a little bit with debris and siltation. Here in the photo, excuse me, we have twin pipe arches. And as you can see, the one on the right is clogged with vegetation. Now, as is often the case with twin or multiple pipes, one of the culverts will carry the bulk of the flow during low flow conditions, and it's not uncommon for one of the other ones, the other one or one of the other ones to silt up and have vegetation accumulate in it. So what happens with this vegetation is it alters flow through the culvert. It may push the flow into one of the barrels or off to the side of one of the barrels, potentially leading to scour at the inlet or outlet, which can ultimately lead to undermining. And in a major flow event, this photo is midsummer and it's not flowing that heavily, but we get a cloud burst. That barrel that's needed to take the additional capacity may be unable to, and that could potentially lead to overtopping of the culvert. So as an owner, we're going to want to try and keep these cleaned out on a regular basis, so they will take the flow that they're designed to take. I will also point out with these multi-barrel culverts, it's not uncommon after a major flow event to have debris accumulating on that nosing area between the two barrels. And that's why, based on my experience, as much as feasibly possible, we try to minimize the multi-barrel culverts because they tend to be an ongoing maintenance issue. We may be getting soil in our culverts. And if we get soil in our culverts, it can and will reduce waterway capacity. Now, there may be a few causes, and it may be on purpose. So the causes could be hydraulics of the stream, and we've got some aggradation, and the stream is tending to deposit soil in the culvert. We may have joints that are failing or an invert that's failing, and that could be causing soil in the culvert. However, we may have installed it that way and have an oversized culvert that's embedded to create as much as possible a natural stream bottom in the culvert. You need to know whether this was accidental or on purpose. And if it was on purpose and the culvert's sized adequately for soils in the bottom and a natural bottom, that's fine. If it wasn't, and if you have something going on, you're probably going to need to clean it out with some regularity so it will continue to accommodate the flow it's designed for. Now, debris accumulating in a culvert can be problematic. This was a case where there was a release due to a dam failure, and it carried a lot of debris, which plugged one of the barrels in a box culvert pier. And you can see there's a fuel oil tank as well as a lot of vegetation jammed up underneath here. So taking the shot back a bit, all the debris accumulated with the large release impeded the amount of water that this culvert could pass, which resulted in an overtopping. and washing out both the embankment above and the approach to the right. Now, I cannot say definitively that had the debris not accumulated there and clogged it, that the culvert would not have overtopped, because it was a pretty significant release. However, the debris did increase the probability of overtopping, and as a result, we now have a crossing that's no longer working, and that required emergency work on the part of, it was New York State DOT at the time, to repair that and get the road open. Okay, we're gonna move on to leaky joints. Joints can leak on us. They can be separated, as we as the upper photo shows. They can be damaged during handling or installation, as the bell in the lower photo shows. And what that will mean is, the joints will be open and we can get material flowing through the joints. Now, the joints may also be open due to poor bedding or subgrade, or it may be a situation where we've got a culvert that's under a fairly substantial fill, and the soils that the culvert is set on settled as a result of that fill. So we want to be conscious of that when we're setting culverts, because if we have a lot of settlement, joints could open up. And the impact of those open joints is we may get water either infiltrating into the culvert, as we see in the photo. It's infiltrating and freezing. We may get exfiltration with water flowing out of the culvert through the joints and carrying soils away. We can get seepage if the water is carrying soils from our fills and backfills. We might get sinkholes in our embankment and our roadway above, and we may destabilize the bedding, which could cause the pipes to move and the joints to open up even more. Here's another case where we have misaligned joints and we're losing quite a bit of soil into the pipe, as well as the failure in the invert, which we have below, which is not helping the situation either. So here's a case where we had a sinkhole, and road was recently paved, and the vibration from the paving operation may have loosened up some joints, and with the subsequent rains, soil washed out, and that little 2-inch diameter hole was a 4-foot diameter sinkhole underneath the pavement where soil was washing through. We could get scour and undermining, and this was discharged downstream of a box culvert, and the heavy flows coming out of this box culvert washed out this bank down below. So often with our culverts, we'll want to do something to abate our flows a little bit, calm things a little bit, so we don't have erosion problems. We can have dense and localized damage, often due to poor installation practices. This particular case, it looks like they backed the track hoe over it, and this can have significant capacity impacts, as it may squeeze down your waterway opening. And this can also limit our relining options. If we can't dig it up and replace it, slip lining isn't something that we're going to be able to feasibly do. And And here's another pipe with a deformation. With concrete pipes, we can get cracks and spalls. Now, how the cracking exhibits itself indicates what's going on. And if we have longitudinal cracks at 12, 3, 6, and 9 o'clock, it's probably due to poor side support. If we have longitudinal cracks just outside the inverts, but parallel, it would be due to poor haunch support. And then with uniform side support, we're unlikely to get longitudinal cracking. Radial cracking or transverse cracking, the location will depend on where we're lacking support. If it's in the invert, we have poor support in the middle of the pipe section. If it's in the crown, we've got inadequate support at the ends, as you can see in this illustration. If uniformly supported, it should sit well. If we don't have support in the middle of the pipe between the bells, we'll get a broken belly type crack. And if the ends are not supported, we'll get a broken back type crack up in the crown of the pipe. Damaged coatings. The damage of the coating in and of itself is not typically a problem. However, it will lead to problems with corrosion. So corrosion can get started when the galvanization is gone. And I bet you can guess from the photo where the normal high water line is for flow in this particular culvert, because it looks like from the spring line up, the galvanization is pretty close to pristine, and below, not so much. Once you have loss of coatings, corrosion will often start, and that will exhibit itself as pitting in the metal. And corrosion is typically due to acidic or saline water, or if your metal pipe is buried in soils with low electrical resistivity. One of the other things that can exacerbate corrosion is loss of coatings due to abrasive bed loads. If there's a lot of sand and gravel washing down the creek at high velocity and chipping the galvanization off, corrosion will get going. And that can lead to invert deterioration, both in concrete and metal pipes. And it can be caused by, in concrete, abrasion in the water or water chemistry. And over time, this deterioration can destabilize the culvert. In metal, water or soil chemistry, damaged by abrasion, and again, it'll destabilize the culvert because it's discontinuous and there's nothing supporting the bottom and can lead to collapse in time. If we have settlements or sinkholes, as shown in the photos, it's a problem for our roadway, but that is an indication of is we have something going on with our culverts that's taking the soils away. So it may be something like a failed invert or failed joints. So we'll need to deal with that problem first before we deal with the actual sinkhole repair. Let's get to the root cause of the issue. And here's a photo with a culvert where the invert is completely gone and the stream is digging a canyon underneath. So the culvert is now undermined. Here we have a complete collapse. Again, not a lot we're going to do from a maintenance standpoint, but we're going to need to replace it. So preventive maintenance. One of the things we want to do is get rid of debris, sediment, vegetation, and maybe armor for scour protection. As we talk, the debris will impair our waterway capacity. So how we're getting rid of silt and debris will depend on what it is and how much room we have to work. Yeah. And what our environmental restrictions are. So things we want to consider: environmental. Do we need to contain that silt and debris? Or do we have an area to capture it? Is it a confined space? Do we have contaminants in the water? So removal of large debris. Do we have things like beaver dams, logs, woody debris? And that often accumulates at the inlets and outlets, and often we can use an excavator or large equipment for that. Sometimes we have to go with, manned entry. Sometimes we use a cable, grapple, mandrel to unplug culverts. If we have silt and smaller spaces, we may need to rely on a vacuum truck, a water or sewer jet, flushing it out with a fire hose, using a bucket line. If we have enough space and the appropriate permits or dry conditions to work, we can use a skid steer loader. I was talking with one of my colleagues who was the bridge engineer from the state of Colorado, and he was telling me his maintenance folks, as much as possible on state roads where they had room, like to have the box culverts sized enough, large enough that they could fit a skid steer in to remove debris. If we have scour at the outlet, it depends on the severity of the scour, how we repair it. You generally want a hydraulics engineer consulting for the appropriate methods and materials. If we're putting in riprap, we want to make sure it's large enough that it's not going to wash downstream in the next storm event. And if we're placing any kind of fill, environmental permits may be required. Here's a video from Michigan DOT. They monster garaged and built their own piece of equipment for placing riprap in a bottomless culvert. They've got this box that they can float, because you're not going to get anything inside a box culvert with a track hoe. And now it's being floated into position. And dropped into place. That's for internally. For externally at the inlet and outlet, riprap can be placed, which will minimize or reduce, both fill in and reduce future formations of scour holes at the inlet and outlet. In some cases, a concrete apron may be what's called for rather than riprap. If you have undermining in your culvert, or it's starting to undermine, or your scour hole is starting to advance under the culvert, to prevent or abate that, installation of toe or cutoff walls may be called for. We may want to repair our inlets. We may look at joint repairs. If we have issues with joints, we may need to repair footings of bottomless culverts, and we can explore relining where we're having overall issues with the culverts. So toe or cutoff walls can be installed in scour prone areas and prevent scour from advancing under the culvert. It won't prevent the scour hole, but it will keep it from undermining the culvert. It's got to be designed to extend well below the expected scour depth, and it will prevent piping beneath the culvert. So the basic procedure for that: stream gets diverted, any backfill gets placed underneath, toe wall gets anchored to the culvert, formed and placed, backfilled with scour resistant material, and the stream gets restored. If we have invert repairs, we can do a concrete paved invert, we can do armor plates, or geosynthetic cementitious composite mat. For concrete paved inverts, stream gets diverted, the invert gets cleaned and repaired, and concrete is placed, cured, and stream flow is restored. This is one New York State DOT did on New York State Route 29. In some cases, if there's abrasion of the invert, a steel plate can be placed in the bottom. This is a California DOT detail. It will spread the flow, so it may not be a palatable solution vis-a-vis DEC, because you won't have a concentrated flow in low flow conditions, but it will resist abrasion and extend the life of your invert. And this is showing an installation being performed with the armor plate in the bottom and up the sides. Geosynthetic mat. Basically, this is geotextile with a sandwich of geotextile with a mortar type mixture between the two plies. And this is rolled out in the invert. The diagram shows a shingle pattern. Virginia DOT has been using this, and they, depending on the size and configuration, will just roll it out in the invert of their culvert. It gets anchored, screwed down to the sides of the culvert, wetted up, and it forms a reinforced concrete shell in the invert. If you have leaking joints, you may want to explore joint repair methods to plug them. This is an extreme case, and it may be beyond any of the reasonable joint repair methods. But internal bands and internal joint seals can be used. Flexible chemical grout injection or concrete collars can be used. Internal bands, this was part of a relining project, but these internal bands are binding the joints together. They are soil tight. They're not necessarily watertight. The bands are placed over the joint and they are tightened with threaded rods. With this type of installation, you'll want to get your bolts or threading up out of the invert as much as possible, and there's still a possibility or probability that under high flow conditions they can snag debris. Grout can be injected through open joints or polyurethane foam to seal them. I've seen this installation used in settlement situations, and it provided a good watertight fix to keep the joints from leaking and keep soil from continuing to flow into the concrete culvert. And then if you have an opportunity, you can dig and expose and pour a concrete collar around the leaking joint, an open joint, and that will also provide a seal. Typically, with the concrete collar, you would want to wrap the opening with geotextile or something like it to prevent the concrete from entering into the culvert while you're placing it. Relining culverts. There are a number of options for relining that can include slip lining, shotcrete or spin cast, depending on the size, or cured in place pipe. Slip lining materials may include corrugated metal pipe, a corrugated metal pipe plate arch, smooth interior metal pipe, which is what we have here, or high density polyethylene. In all cases, we're putting a smaller pipe inside the existing pipe, and that will reduce our hydraulic capacity. But in many cases, we can either deal with that loss of capacity, or in other cases, with a smooth interior metal or polyethylene pipe, the going from a corrugated to a smooth will help minimize the reduction in hydraulic capacity, depending on the design and performance of the culvert. This series of photos shows our Washington County crew slip lining a new corrugated pipe arch in an existing bottomless pipe arch on one of our county roads. And this was a plate arch, and you can see individual plates were bolted together. In the A photo, new footing was formed just inside of the existing footing. The culvert arch was erected and slid into place. And here you can see it was in C, it slid into place and it was on a skew. And then D, the area was formed up, so concrete could fill that annular space between the existing culvert and arch and the lining. Because of the skew, it was a little bit challenging to form it up. And then we had the opportunity to use self-consolidating concrete from the top, and we cut into the top of the old culvert and basically put a port in to grout it. And in the photo below, we have a spiral ribbed metal pipe, which is a much smoother lining, and that was slid into place. And you can see in the photos we have grout ports And those were used to route the space between the existing and the new liner. And now we have a new basically corrugated steel sandwich. Here's a photo of a smooth polyethylene pipe liner. And this was a much smaller diameter, and the pipes are in that annular space are what were used to inject the grout. If you have some distortions, a concrete interior can be used. And basically, it provides a uniform thickness over the whole interior of the pipe. The photo shows spin casting, which is basically a small sled that projects concrete, essentially shotcrete, onto the interior of the pipe. This system is much more forgiving of distortions than slip lining, but you have to clean and grout any voids before you start. And if you have a larger pipe where you have the space to operate, the interior can be shotcreted. Again, but you have to have the room to work. Otherwise, a spin casting and dragging the sled through may be the more appropriate fix. I don't know if anybody has had any exposure to cured in place pipe. Basically, what this is a felt liner, a polyester felt liner that's impregnated with an epoxy resin. And it's installed using water or air pressure, pushing that liner up against the walls of the existing culvert. And it's cured with hot air or hot water. It'll take the culvert out of service while it's happening, but once it's cured, you have a brand new basically polyester pipe. We recently used this on a number of culvert crossings on Quaker Road in Warren County this past year, because the road was very busy and could not be easily taken out of service for open cutting. And it's a little more expensive, but in many cases, it's cheaper than fooling around with deep cuts. The way this process works is it was originally developed for sewer pipes, but it can go up to like 6 foot or so in diameter. The tube is inverted and often pushed into place with water, and the water holds it against the existing pipe and is heated and allowed to cure. And then you have a brand new, very smooth liner. This is how the insertion process looks at the outlet end. So if you're doing footing repairs to bottomless pipes, it's similar to doing other concrete repairs, but the real challenge there is tight spaces, making equipment use difficult. Similar to the photo with that archery lining, getting in there to pour that footing was a challenge, and it was a lot of handwork and manual labor. So what you'll need to do is divert the stream around away from one of the footings. Make sure you get down to sound concrete. Make sure repairs extend below scour depth. And here's case in progress. We have bypass pipe. Determine the extent of repairs. Install rebar. clean and form, and then place bonding agent, place concrete, cure the concrete, and then reestablish the stream. So, in summary, we've discussed a lot of common deficiencies in culverts, including coatings, joints, cracks, debris. We've described preventive maintenance, basically cleaning and repairs of joints. And we've reviewed repair of culverts, including linings. So now we're going to move on to our review questions. Corrosion in metal pipes can lead to which of the following deficiencies? Invert damage, deformation, undermining, or all of the above? Okay, so the answer we're looking for is all of the above. It can lead to undermining as we get perforations, invert, and deformation as we lose support. So, next question. What would be preventative maintenance method for prevention of scour? Placement of riprap, installation of toe or cutoff wall, slip lining or cured in place pipe, installation of geosynthetic composite mat, A and B only, or all of the above? Okay. So placement of riprap or concrete apron will help to prevent scour. Installation of toe or cutoff wall will not necessarily prevent the scour, but will prevent it from being undermined. Slip lining or cured in place pipe could potentially exacerbate scour because it may increase velocities through the pipe. And geosynthetic composite or armor plate probably will not have an impact one way or the other. So the answer we were looking for is A and B. You know, E was the answer we were looking for. So, which is not a viable method for lining a culvert with significant deformations? Cured in place, shotcrete, slip lining, or none of the above? Okay, so cured in place and shotcrete will both work for if you have some deformations in your pipe because they are somewhat forgiving of those. They will go over and around those. Slip lining is going to be a lot less forgiving. And if you have deformations, that will not work. And I'm going to caveat that by saying, if it's really significant, you're not going to do any lining option. You're going to replace it. So that concludes our discussion of culverts this morning. I want to thank everybody for their attention and participation, and I hope you got something out of it. Thank you very much. see.
Looks like no more questions.
Okay,
You're off the hook.
great.
Next week, we're gonna be doing, finding employees. That could be important for people. And then work zones. So look forward to seeing folks on future webinars, and thanks, Willie.
Thank you.
Everybody have yourself a great day. It looks like a nice sunny one out there. Okay. Bye-bye.